In a business, a lot of things that happen in the background are underappreciated, and backup is one of them. It is rarely asked for, but it is the most sought after if something bad happens to your data. Whether it is a ransomware attack, or data accidentally deleted, or there's a hardware failure. In this episode, I will talk about what all to consider while designing a data backup and restoration strategy. If you are in DevOps, or are managing IT infrastructure, or are running a business where you have to rely on data availability, then this video may be of some value. In an enterprise, a typical technology landscape has some sort of a business continuity and a disaster recovery plan. Backups are an integral component of that. The common knowledge is that you zip a folder and save it someplace safe, such as Google Drive, or use Apple's Time Machine, and you are good. But as a business owner, to maintain business continuity and having a usable disaster recovery plan, you first need to answer a few key questions. The first question is, what is the RPO, the recovery point objective of your organization? In case of a disaster, how much data loss your organization is willing to suffer? 3 days, 12 hours, or 1 hour? That eventually will determine the data backup frequency, its strategy, and the costs. The second question is, have you set the RTO, the recovery time objective? That is, in case of an IT incident, how soon you need to recover the data and make the systems running. Then, how many days worth of backup do you need? The answer to it might also depend on the agreements with your customers on the data backup and storage requirements. And finally, would you need the data as a hot backup, which means it is readily available for restoration, or could it be a cold backup, which might mean it is written on a slower or a cheaper storage medium for archival and long-term storage? Hot backups will be the ones that will be put to use in case of an IT incident and will contain data that is essential to run a business. On the other hand, the data that is required for auditing or legal reasons can be considered as cold backup. Just remember, hot, warm, and cold backups have different meanings depending on the context. The answers to these questions will then be used by the IT team to build a data backup strategy and provide you with a cost estimate. As part of an IT team who is responsible for business continuity and disaster recovery planning, you need to get clarity on the business objectives in terms of RPO and RTO, etc., from the stakeholders. You then also have to consider other parameters to define your backup strategy and capacity planning. The first question you need to answer is, what type of backup? A full backup each time, or taking a full backup for the first time and subsequent backups are to be incremental? The next question is, how will you address the ever-growing storage? Do you have sufficient hardware and redundancy, or will you be using cloud storage? Then, how much are you willing to spend? The expenses could be related to storage, data transfer costs, hardware, licensing, and personnel costs. What about taking backup of databases, which are changing in real time, or software that keeps data in memory rather than writing on a disk? How will you address those situations? The most important question would be, how would you ensure data security? Is encryption also required for data at rest, especially if they are transferred to a secondary location? Finally, how would you determine whether you can rely on the backups that you have created? Do you have a sandbox environment where you can restore and test the integrity of the backups you are creating? When you devise a data backup strategy, you have to first identify your audience and get a sense of how important the data is for them. You have to realize that unless it is just files, such as PowerPoint or Excel spreadsheets, they may not always know where all their data is kept. If they are using a CRM application, then it is possibly maintaining its data in a different location. Or if they have a database or Docker containers, then it might be difficult to identify the actual path where the data resides on that system. It is your duty to guide them. For individual users, it is best to have at least some backup solution in place. Apple Mac OS has Time Machine, Microsoft Windows has Backup, Linux has a few equivalents such as Deja Dupe and Chronopeat. These backups can be moved to a remote location or to a portable hard drive periodically. But in an organization that has multiple servers running alongside user machines, there is a need to have a more central and robust backup mechanism. For that, the easiest next step is to move towards full and incremental backups. The backups are done either manually or automatically at predefined intervals. They are easy to implement, especially in smaller organizations, though they require monitoring, and the IT team needs to work with the business team to identify the frequency and the schedule of backups and set expectations on the restoration and data availability. There are off the shelf solutions that help you do that. They are expensive, but they can scale enterprise wide and take the load off from your shoulders in terms of logistics. They can do backup, scheduling, and recovery at an enterprise level, including special scenarios such as database servers, Microsoft Exchange, or Active Directory. For large organizations, it works out quite well since there is software support and usable graphical interfaces to manage the backups and scheduling. If you are enterprising enough, you could do the same through free and open source tools too. The only disadvantage would be that, unlike a mostly predefined methodology offered by enterprise backup solutions, you will be dictating the backup strategy end to end, and you will be on your own identifying and addressing the points of failure. The gold standard for taking backups is CDP, continuous data protection. In a CDP type setup, every save is backed up, effectively creating multiple versions of a single file. Instead of synchronizing file level differences, it saves the underlying block level or byte level differences. That means if a few bytes are modified of a 100 MB file, then only those modified bytes will be synchronized, not the entire file, thus saving storage and bandwidth. Since it is near real time, of course, ignoring the network transfer differences, theoretically it can offer an RPO, the recovery point objective, of 0. That is, in case of a major IT incident, the chances of data loss are 0. Practical implementations, though, shifts between continuous and near continuous. For the cloud environments, such as AWS, and virtual machines, such as VMware or Zen or KVM, there are options of creating snapshots, which take backup of the entire setup periodically. You may utilize them too. I work with a number of small and medium enterprises, and I have noticed that a daily incremental backup is good enough for a majority of use cases, especially for software development teams or the DevOps teams who are managing a select set of servers. Having control of backups provide a peace of mind and a good night's sleep. Since I manage a large set of Linux servers, I always gravitate towards rsync, which allows me to create differential backups without any prohibitive costs and provides more control on my setup. In the next episode, I will talk about some open source or free tools, including rsync, that you can smartly stitch together to create an effective data backup strategy, as well as prepare an environment where you can try out the data restoration ability. Stay tuned.